Dear students, in last class I have explained charges and the properties of the charges, then how to measure the various densities of charge. So, one more important property of the charge is that like charges repel and unlike charges attract each other. So, what do you mean by like charge? Like charge means they are identical in nature. That means if one charge is positive, other charge is also positive. If one charge is negative, the other is also negative. So, like charges, they repel each other. So, there will be a repulsive force between two identical charges. Whereas, the unlike charges, that means that they are opposite in nature. If one is positive, other has to be negative. They always attract each other. So, what is the important property of the charges? Like charges, they repel each other. Unlike charges attract each other with a force, and that force is called electrostatic force. Okay. So, we call that force as electrostatic force. So, electrostatic force acts between two charges, either like charges or unlike charges. If it is unlike charges, they attract each other, and if it is like charges, they repel each other. How to find this particular force? To find the force, we have an important law given by Augustine Coulomb, and it is called Coulomb's inverse square law. This particular statement, it has appeared, you can see almost 6 times in the examination. So, that is why statement is very important. Okay, state and explain. If it is only, if they ask only state, then give the statement of the law. And if they ask state and explain, then along with the statement, do write the mathematical form also. Okay. So, now let us focus more on this particular law, which is Coulomb's inverse square law. Now, what is the use of this law, correct? And then what is the mathematical form? So, that is what I am going to explain. So, I am going to consider first two charges. I can consider like charges or unlike charges. So, let plus q1 be one of the charge separated by a distance r from another charge q2. So, plus q1 is one point charge, plus q2 is another point charge, and r is the separation between them. Okay. Now, they are like charges, correct. So, what is the nature of the force between them? Repulsive. So, this charge repels this charge in this direction with a force F, and the second charge also repels the first with the same force. So, that is why it will be like this, where F is the electrostatic force of repulsion between the two charges. What if I take one positive plus q1 and the other negative minus q2 separated by a distance r? Then first charge attracts the second charge towards it in this direction with the force F. Second charge again exerts the same force which is attractive. So, second charge attracts the first towards it. So, this is how the force acts between the two charges. Okay. So, repulsive force, attractive force. And now, what is the magnitude of this force and how to find this particular force? You know, this statement of the Coulomb's inverse square law is similar to that of Newton's law of gravitation. Just recall that if m1 and m2 are the two masses separated by distance r, then F is directly proportional to the product of the masses and inversely proportional to square of the distance between them. And only thing now, instead of the masses, you have to replace by the two charges, and R is the separation between the two charges. So, that is the mathematical form. So, let us go through the statement first. So, F is the electrostatic force. Electrostatic force between two static point charges, static because they are at rest. So, electrostatic force between two static point charges is directly proportional to product of the magnitude of the charges. Why magnitude? Because we have to consider only the positive sign, we do not consider the negative sign. Product of the magnitude of the two charges and inversely proportional to square of the distance between them. Understood the statement? So, let me repeat. Electrostatic force between two static point charges is directly proportional to product of the magnitude of the charges and inversely proportional to square of the distance between them, and the mathematical form F is given by 1 by 4 pi epsilon naught Q1 Q2 by R square. Q1 Q2 by R square, I have written it. But what is this 1 by 4 pi epsilon naught? You know, we write epsilon like this. This is epsilon naught. Okay. So, in Newton's law of gravitation, the proportionality constant is G, capital G, which is called a gravitational constant. But here, the constant of proportionality is 1 by 4 pi epsilon naught. And when we write this equation, this is in air or vacuum. Now, what do you mean by air or vacuum? That is, the space between the two charges is filled with air or vacuum. Imagine if there is a medium in between the two charges. Medium, let me write that here. F is equal to 1 by 4 pi epsilon naught epsilon r into Q1 Q2 by R square. So, this I will write F suffix A stands for when the space between the two charges is air. And if there is a medium, I will write M. Okay. Then the equation slightly changes. That is 1 by 4 pi epsilon naught, one more term comes epsilon r, that is related to the medium, and then Q1 Q2 by R square. Or in simple, electrostatic force depends on the medium between the two charges, whereas gravitational force is independent of the medium. Okay. Gravitational force does not depend on the medium, whereas electrostatic force depends on the medium between the two charges. Okay, let us learn more about this entire constant now. Okay, this constant. So, in air, the equation is 1 by 4 pi epsilon naught Q1 Q2 by R square, whereas in a medium, it is 1 by 4 pi epsilon naught into epsilon r Q1 Q2 by R square. Now, let us start with epsilon naught. What is epsilon naught? This epsilon naught is called permittivity. Okay, permittivity, double T here. Okay, right. It is called permittivity of free space, and it has a value. The value is 8.854 into 10 to the power minus 12. Okay, farad per meter is the unit which you have to remember. So, what is the value of epsilon naught? It is a constant 8.854 into 10 to the power minus 12 farad per meter. Then, what is epsilon r called? Epsilon r. Epsilon r in simple called dielectric constant. Okay, dielectric constant. Now, what do you mean by the word dielectric here? Dielectric stands for a type of insulator. Okay, dielectric is an insulator. Dielectric constant, and this has no unit. Okay, and the least value of epsilon r is 1. That is for air or vacuum, and the value of epsilon r is infinity. That is for conductor. So, do remember the value of epsilon r. The least value is 1, highest value is infinity, and it has no unit. Okay, and this product, product means epsilon naught into epsilon r. We write it as epsilon. Okay, so epsilon is nothing but epsilon naught into epsilon r, which is called absolute permittivity of the medium. Absolute permittivity of the medium. Okay. So, that is the product. Okay, right. So, hope you have understood here. So, equation for force is 1 by 4 pi epsilon naught Q1 Q2 by R square in air or vacuum, whereas Fm is 1 by 4 pi epsilon naught into epsilon r Q1 Q2 by R square in a medium. Moment there is a medium, one more term comes epsilon r. Otherwise, we write only 1 by 4 pi epsilon naught. Why? Because the value of epsilon r is 1 for air or vacuum. So, when this value is 1, we get only 1 by 4 pi epsilon naught. Okay. So, this is how the two equations differs, and hope you have understood the formula used to find electrostatic force between the two charges. Let me repeat this statement as it is important. Electrostatic force between two static point charges is directly proportional to product of the magnitude of the charges and inversely proportional to square of the distance between them. If you repeat the definition, it is easy to remember. Okay, and this is the mathematical form of it. Force is a vector quantity. So, how to write the expression for force in vector form. Expression for force in vector form. So that's what I am going to write here. The equation is like this: F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. So if you want to write in vector form, F is a vector, force is a vector, that's equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Write the same and then introduce a unit vector, which is R cap. So this is the expression for force in vector form, okay, where what is R vector? It's a unit vector in the direction of the force. Therefore, if they ask in the exam, write an expression for force in vector form, then do write this expression and explain the terms, okay. What is epsilon naught? Permittivity of free space. What is the value of that? 8.854 into 10 to the power minus 12 farad per meter. What is Q1 Q2? Two charges. What is R? Separation between the two charges. See, whenever we solve a problem, every time we come across this value, 1 by 4 pi epsilon naught. So I will simplify this. 1 by 4 pi is a 3.142 into the value of epsilon naught, 8.854 into 10 to the power minus 12. And now when I simplify this, I will get this value 1 by 4 pi epsilon naught to be approximately 9 into 10 to the power 9. Okay. So therefore, here onwards, whenever we come across 1 by 4 pi epsilon naught, we are going to replace it as 9 into 10 to the power 9, whereas the value of 4 pi epsilon naught is 1 by 9 into 10 to the power 9. So do remember this. That is the value of the constant. You don't have to waste time substituting for epsilon naught, pi and all. Straight away you can write 1 by 4 pi epsilon naught is 9 into 10 to the power 9 value. Okay. Now let's see some of the question asked in the examination for 1 mark, and then we'll attempt as how these kind of questions can be attempted. It's a 1 mark question. How does electrostatic force between the 2 point charges change when a dielectric is introduced between them? See, equation for force is given by 1 by 4 pi epsilon naught epsilon r into q1 into q2 by r square. So what is the least value of epsilon r? That's 1. And for all other medium, it is greater than 1. Okay, like epsilon r is equal to 5. Okay, for glass. Epsilon r is equal to 80 for pure water, and epsilon r is equal to infinity for conductor. So it's a different for the different medium, but the least value is 1. So if you introduced a dielectric medium, imagine if I don't write like this. What this means? It means that the force is measured in air. And now if I introduce a dielectric medium, then the denominator value increases. Correct, no? Denominator, when we introduce a medium, like okay, I can introduce a paper or a glass, then this increases. And how force varies with the dielectric constant? It is inversely proportional, right? So when this increases, force has to decrease. So therefore, answer to this question is, in the exam you have to write only this much, okay? Force decreases, okay? And if you write this correct answer, your mark increases, okay? All right. So hope you understood this 1 mark question. Very simple. Let's see what is the next question. Write Coulomb's inverse square law in vector form. I have just now explained. It's a 1 mark question asked in March 2015. So vector F is equal to 1 by 4 pi epsilon naught q1 q2 by r square into r cap. So on both the sides, vector should be there. See, left hand side there is a vector which is a force, and on the right hand side there is a unit vector. So that is how you have to write. If they ask explain, then explain the terms. Clear? 1 mark. Again, one more easy question. Okay. Okay. So let's see important question again. Define Coulomb or unit charge, or define SI unit of charge. Same thing. Whatever they may ask, define Coulomb, or they may ask define unit charge or define SI unit of charge. The answer is the same. Okay. So let's define. So for that, I'm going to use the equation F 1 by 4 pi epsilon naught q1 q2 by r square, and then even I will use epsilon r here. Okay, right. So, to define 1 coulomb, I am going to consider q1 is equal to plus 1 coulomb. Okay, and then I am going to place it in vacuum, and then at a distance of 1 meter from equal and similar charge. See, equal in magnitude and similar in nature. Okay, everything you take 1 coulomb. Epsilon or 1 means it's in free space. Free space means vacuum only. Okay, free space or vacuum. Separation 1 meter. Again, it's 1 coulomb. Understood this? Right. Now, if everything is 1, check this. Q1 is 1. This Q1, I'll substitute here. Okay, Q1 is 1. Q2 is also 1. By R is 1. Epsilon R is 1. Okay. Now, what is left after that? What is left is only 1 by 4 pi epsilon naught. Correct? Only this much is left if everything is 1. 1, 1, 1 and 1. What is the value of 1 by 4 pi epsilon naught? It is nothing but 9 into 10 power 9. Just now I had given that. So, therefore, force becomes a 9 into 10 to the power 9 what? Newton. So, with this, it is very easy to define 1 coulomb. Okay. See the statement. 1 coulomb is defined as that charge which, when placed in vacuum or free space at a distance of 1 meter from an equal and similar charge, repels it, this will repels it with a force of 9 into 10 to the power 9 Newton. Okay, important definition. So, listen, 1 coulomb is defined as that charge which, when placed in vacuum at a distance of 1 meter from equal and similar charge, equal in magnitude, similar in nature, repels it, because when they are like charges it will repel, right? Repels it with a force of 9 into 10 to the power 9 Newton. I will repeat the statement. 1 coulomb is defined as that charge which, when placed in vacuum at a distance of 1 meter from an equal and similar charge, repels it with a force of 9 into 10 to the power 9 Newton. So, that is that definition, important, and do study all these questions that have appeared in the examination, because these questions will be repeated. It is very easy to score in the exam. Hope you have understood the definition of all this and the kind of the question that have appeared for 1 mark in the examination. Now, let us solve one numerical which is there in the study material, and you have to start writing these questions that have appeared in the examination, question answer in your notes. Let us go through the statement. What is the statement? The electrostatic force on a metal sphere of charge 0.4 microcoulomb due to another identical metal sphere of charge 0.8 microcoulomb in air is a 0.2 Newton. Find the distance between the two spheres. Okay, so first let us calculate. So, here there is a sphere. So, there is a sphere, and the charge on it is Q1 I will write, which is 0.4 microcoulomb, correct? It is 0.4 microcoulomb. I will write slightly to my left here. Okay. So, this is Q1 0.4 microcoulomb. Okay. So, this is a sphere. Then due to another identical metal sphere of charge identical minus 0.8 microcoulomb. So, here we have another identical which is Q2 minus 0.8 microcoulomb. Okay. In air, it is given they are in air, and let them, they are separated by a distance r like this. And force is given in air. How much? What is the value of the force? It is a 0.2 Newton. 0.2 Newton. So, they have asked what is the, find the distance between them. I have to find the value of the distance. How much is r? So, first let us calculate this, and then we will come to the remaining statement. So, force is given by F is equal to 1 by 4 pi epsilon naught. It is in air. So, epsilon r is 1, Q1 Q2 by r square, correct. So, here I wanted r square. So, rearrange. R square is equal to 1 by 4 pi epsilon naught, which is 9 into 10 to the power 9 into product of the magnitude of the charges. So, 0.4 and then micro 10 to the power minus 6. Magnitude means you have to consider only the positive value 0.8 micro 10 to the power minus 6 divided by the force. You have to bring the force this side. How much? What is the force? It's 0.2. 0.2. Okay. All right. So let's simplify this. This 0.22 here twice. Correct. So this is 9 into 0.8 into 2 is 1.6 into. Then we have 9. This is minus 12. Correct. Minus 12 and 9 is 10 to the power minus 3. Correct. Minus 12 plus 9 is 10 to the power minus 3. Okay. 9 minus here we get minus 9 minus 3 is nothing but minus 12 here. Okay. Now what I'll do is I'll just rearrange this. Okay. It's a 9 into, I will multiply here by 10, I'll divide by 10. Okay. When I multiply by 10, I'll get 16. When I divide by 10, that 10 I can take to the numerator so that it becomes 10 to the power minus 4. Now the reason why I have adjusted this, because it's a r square, so that when I take the root, it's easy for me to simplify. Okay. So that is the reason why 1.6 was made 16 by multiplying by 10, dividing by 10. Multiplying by 10 will give you 16, divide by 10 will change this power to 10 to the power minus 4. So this is r square. Okay. Now what's r? Take the root of 9 into 16 into 10 to the power minus 4. Very simple. Root 9, 3. Root 16, 4. Root of 10 to the power minus 4, 10 to the power minus 2. Correct? Okay. That's 4, 3, 12 into 10 to the power minus 2. So much meter is the answer. That is the first part. What is the next part? See the next part that is given. Okay. Find the distance between the two spheres, that is over. And also the force between the same two spheres when they are brought into contact. See these two spheres, they are brought into contact. Okay. And then replaced in their initial position. So first the two spheres are brought into contact and then they are replaced back. And once they are replaced back, what is the new force? That's what I have to calculate. Okay. All right. So let's calculate that part now, which I'm going to write here. When two spheres are brought, they are in contact. Okay. They are brought in contact. So which I'll draw here. So when they are brought in contact, remember the size of the sphere will not reduce. Okay, it is the same sphere, just the representation. When they are brought in contact, now what happens is, what is the net charge now? Okay, when they are brought in contact, the net charge will be 0.4 and minus 0.8, plus 0.4 and minus 0.8 microcoulomb. Okay, microcoulomb. How much is that? Plus 0.4. Okay, plus 0.4 and minus 0.8. So that will be minus 0.4 microcoulomb. Am I right? Plus 4 and minus 0.8 will be minus 0.4 microcoulomb. That is the total. Okay. So then what is the charge on each? On each the same charge is shared equally. Correct. So that will be minus 0.4 microcoulomb by 2. That will be minus 0.2 microcoulomb. So now the charge on both the spheres here is minus 0.2 microcoulomb and minus 0.2 microcoulomb. Okay. Because same charges, since they are identical, the same charge is shared equally, on both the spheres. And now they are separated by the same distance. What are the distances here? 12. 12 into 10 to the power minus 2. Okay, meters. That is that. And now we have to find the new force. Okay. So let this new charge be Q1 dash, this be Q2 dash. So therefore, the new force, which I'll write F dash, is equal to 1 by 4 pi epsilon naught Q1 dash into Q2 dash by R square. That's 1 by 4 pi epsilon naught, 9 into 10 to the power 9 into, what are the two charges here? One is a 0.2 microcoulomb, 0.2 into 10 to the power minus 6 into another 0.2 in 10 to the power minus 6. Remember, we consider only the magnitude. We don't substitute the minus sign here. Okay. Divide by. So this is 12 here. Okay. 12. 12 in 10 to the power minus 2, square of it. So that will be 144. Okay. 144 into 10 to the power minus 4. 10 to the power minus 4. Okay. Right. So let's simplify this here. So we have 9 into point. Okay, let me simplify this first. 0.2 into 0.2. So that will be 0.04. Okay, 0.04. 0.2 into 0.2 is 0.04 into 9. So that will be 0.36. Okay, that will be 0.36 into 10 to the power 9 and again minus 12. So that will be 10 to the power minus 3. Okay, divided by 144 into 10 to the power minus 4. Correct? Yes. Okay. Now that's equal to, I can simplify further here. See, 10 to the power minus 3 and this 10 to the power minus 4 becomes plus 10 into 0.36 becomes a 3.6. Correct? 144 as it is. 10 to the power minus 4 when taken to the numerator becomes 10 to the power plus 4. Plus 4 minus 3 is plus 1 and when you multiply you get 3.6. Okay, divided by 144. I'll rearrange here. So this will be equal to simplify, I'll write this as 36 into 10 to the power minus 1. Okay. So you can use the calculator, but I'm trying to simplify it without using the calculator, right? 36 into 10 to the power minus 1 divided by 144. Because 36 into 10 to the power minus 1 is nothing but 3.6. Okay, right. Now see the multiple. This 36 here 4 times. 36 into 2, 72. 72 into 2 is 144. Correct. So this is 4 times. This is 1 by 4 into 10 to the power minus 1. See, 1 by 4 is nothing but 0.25. 0.25. Okay. Into 10 to the power minus 1. So that will be 0.025. Okay. Newton. So that's the answer. Okay. So the new force is 0.025 Newton will be the new answer or the new force which they have asked. So hope you have understood this numerical, okay, which has appeared in the model question paper. Okay, right. Now what I have explained right now is force between two charges only. Correct. Now what if there are many charges, system of charges? What if there are many charges or system of charges? Okay, something like this. So here we have a charge Q1, then there is Q2, then there is Q3, then this is Q4. And I want to find the net force on this particular charge. So Q1 experiences force due to Q2. It experiences force due to Q3. It experiences force due to Q4. So the net force on any charge is equal to the vector sum of the forces due to the individual charges. So this is how we calculate. The net force on any charge due to number of charges is equal to vector sum of the forces due to the individual charges, and this is called principle of superposition of forces. So we can use the principle of superposition of forces to calculate the resultant force on any single charge due to number of other charges. So the rest of the topic of this particular chapter I am going to continue in my next class. So whatever the topic that's done and whatever the question that have appeared in the examination, please write the question and the answer in your notebook and maintain it neatly. And if you have any clarification, feel free to clarify your doubts in our group. Thank you.